Hi everyone, this video is an introduction to statistics and contains some basic concepts and key terminology. It's a high-level introduction into what statistics is and some of the things you might encounter when studying statistics. Specifically in this video, we'll provide an overview of what statistics is and the statistical investigation process, including data collection, data types, organising and displaying data, analysing data, interpreting and forming conclusions. The discipline of statistics involves collecting, analysing, interpretation, and the presentation of data, which is why many of the decisions we make today are based on statistical analysis. The type and amount of product stocked on the supermarket shelf, for example, is determined by sales statistics. Statistical literacy is increasingly important and required to participate in everyday life. Statistics are utilised across many disciplines, including but not limited to maths, accounting, economics, banking, astronomy, as well as natural and social sciences. For example, suppose we measure the weight of 100 patients in a study. With so many measurements, simply looking at the data fails to provide an informative account. However, statistics can give an instant overall picture of the data based on graphical presentation or numerical summarization, irrespective of the number of data points. So why do we study statistics? It's difficult to go through life in the 21st century without encountering some form of statistics. For example, at school or at work, in the weather report or during sporting events. Whether we like it or not, by using social media, by using loyalty cards at supermarkets, our data is being collected and analysed and interpreted for the benefit of the large multinational companies. Advances in digital technology are allowing anything that can be captured in the form of data to be captured, stored and analysed. For this reason, statistics is extremely relevant in everyday life. Here I have a screenshot taken from Google Trends, analysing search terms for Toyota and Ford, which are two well-known motor vehicle brands. This shows how often they are searched worldwide over a 12-month period. Search engines such as Google not only find web pages, but they analyse and categorise searches. If the entire world's Google searches for 1 month were listed in a single document, it would be an incredible list. Search engines employ computer software engineers who are also highly skilled in mathematics, especially in statistics. In the case of Google, they organise worldwide searches into categories and present comparisons such as this using graphs. This provides much more interesting and useful information for groups such as online shoppers, politicians, the entertainment industry, and so on. And people like even you and I can go onto Google Trends and have a look and search for words and see how often they're searched. This is really interesting to do, especially if you're maybe starting a business in your local area or in your country. You might be able to go on and have a look. Here I've shown another graphical representation, except we've got the graph is comparisons between regions or between countries and whether they're searching for those terms. This would be very important for, say, Toyota or Ford to go in and have a look and completing their market research to see which countries are really searching for their brand. This might determine whether they enter or exit a certain region or country. And this sort of thing is all driven by the data that underlies the searches through Google. In a statistical investigation process, we collect information about a group of individuals, then we analyse the information to draw conclusions. The statistical investigation process follows can be written out in a number of steps. This is dependent on the text we're using. Some texts are different. Some might use 5 steps, some might use 6 or 7. And these steps generally, though, follow the same order. So here I'm breaking it down into 5 steps. So first step is to state the problem or question. It's important to also pose the correct question to answer. And the next step is to collect the data from the target population. And then we organise and summarise and display the data. Then we analyse the data. And then we interpret and form conclusions. Another step after this might be also including writing a report or article or whatever you're going to use your investigation for. might be another step that you add to this process. We'll now look at some of these steps in a little bit more detail. Please keep in mind that this is an introduction. I have other videos that look at these items in more detail. For many statistical problems, there's a target population. This is a group of things or people we're interested about finding information about. Examples might include people of a country, the students at school, or the members of a sporting club. The most accurate way to investigate a population is to conduct a census, which involves obtaining data from every member of the population. There's very rarely enough time or money, though, to gather information from everyone or everything in a population. Therefore, the goal becomes to find a representative sample or subset of the population. One way to do this might be through a survey, and you might have done these before. We're going to look further into two types of data, both which have two subtypes. The first type of data is called categorical data. This is data that can be described as a category or a group. This can be broken down into two subtypes. The first being nominal, which means there is no order, for example, colors or gender. The second categorical subtype is ordinal. There are categories that have some form of order, for example, low, medium, high. The second data type we will look at is numerical, which is basically numbers. The second data type can also be broken down into two subtypes. There's discrete. That means there is a limit to the number of values. I usually think of counting, for example, counting 1, 2, 3, or integers or whole numbers when we're talking about discrete numerical data types. The second numerical subtype is continuous. These are things that can take any value in a range. They are usually measured, for example, the length of something or the weight of something. The accuracy of a measurement usually depends on the measuring device. So whether we're weighing something in the science lab or measuring the height of someone, the continuous data could be measured to any number of decimal points, but that depends on the measuring device we're going to use. So organizing and displaying data occurs after data collection. The type of display will be dependent on the type of data we collected. Here we have a continuous numerical data. It appears discrete, but don't forget the number of hours watching TV could be measured even more accurately by confirming how many minutes or seconds. This data has been estimated based on hours. You may recall from your previous studies how to tally. You tally in a group of 5. So you do 4 straight lines, and then you put a strike through the 4 to indicate that you've counted 5. Because we have continuous numerical data, we usually group the values like this and display in a frequency table to identify how many fall within a particular group. Here we have the number of hours of TV watched. We've grouped them from 1 to 3 hours, 4 to 6, 7 to 9 hours. So a frequency table, this is a frequency table, shows the number of values that fall within a set of categories or class intervals. Here we have class intervals. So grouped numerical data can be illustrated by a histogram. The height of the columns correspond to the frequency of the values in the interval class. Therefore, we usually have no gaps between the columns because this is a histogram and our items have fallen between 1 and 3, for example, in the first column. And then the next column, we start straight at 4 to 6. We don't have a gap between the columns because our data values could have fallen anywhere between those numbers. Say we watched 2.5 hours, we would be between 1 and 3, but it would only be recorded as between 1 and 3, and therefore we don't know, based on the histogram, where it fell within the class interval. So statistics gives a way to understand many parts of our world, from weather patterns to outcomes of horse races. By taking a large amount of data, people can understand complicated principles and even predict the future with high accuracy. Graphs and tables are the most common way to represent data that's been collected. Common types of graphs that you might see when we're looking at statistics are scatter plots. We've just scattered we just put dots on a sort of a Cartesian plane mapped against two axes. We have histograms, and we saw that on the last screen. There's pie charts, there's line graphs, box and whisker plots, and column or bar graphs are very similar. As I've shown here, there are many different ways to display data, and these can be formatted in a number of ways that are visually appealing to the reader. And we'll look at a few of these in more detail in other videos. Following organising and displaying data, we want to analyse it. We'll delve further into these in other videos. The first things we usually learn are the measures of centre, including the mean or average, the median, and the mode. These are all ways to describe the centre of a data set. After the measures of centre, we usually go on to learn measures of spread, including the range, including minimum and maximum values, interquartile range, which includes calculating the quartiles, as well as the standard deviation. These are all measures of the spread of the data. In addition, we'll look at outliers, which is anything outside of what appears to be outside of the normal data set. We'll look at these further in other videos. After analysing the data, it's time to interpret the results and form conclusions. This is usually done in a report, but you will see reference to data analysis in things such as news articles and opinion polls. The Australian Bureau of Statistics, or ABS, is Australia's national statistical agency, providing trusted official statistics on a wide range of economic, social, population, and environmental matters. And this stuff is important to Australia, so ABS collects and provides a lot of data for analysis in Australia. You can go onto their website and have a look at a lot of the information that they've collected. So, in summary, in this video, we've introduced statistics and the statistical investigation process, including data collection, data types, organising and displaying data, analysing, interpreting and forming conclusions. In future videos, we'll look at these in more detail. Thank you.